Building a 1:1 current balun is one of the most effective ways to prevent common mode current from flowing down the outside of your coax, to be exact, on the outer surface of the coaxial shield. This keeps RF out of your shack and ensures your antenna radiation pattern stays true to the design. Using RG316 on a proper ferrite core is an excellent choice for 400 watts, as it is high temperature Teflon insulated coax that can handle the heat. I have chosen 400 watt for the discussion, as that is the legal limit for my class of license, though I do not have a 400 watt radio. First of all, we need a toroid core, an FT240-31 or 240-43. Type 31 is generally better for the lower HF bands like 40 to 160 meter. Type 43 is a great all-rounder. Coaxial cable, approximately 20 to 24 inches of RG316. Enclosure, a weatherproof electrical box, example a 4x4x2 PVC box. Hardware, 2 SO239 connectors or 1 SO239 and 2 stainless steel binding posts for wire antennas. Heavy duty zip ties, 3M glass cloth tape, optional to protect the core. Before winding, it is helpful to wrap the ferrite core in a layer of fiberglass tape. Ferrite can be abrasive, and this tape prevents the core from nicking the jacket of your RG316 over time. For a 1:1 current balun, we use a crossover winding known as W1JR crossover technique. This places the input and output on opposite sides of the toroid, providing better isolation. Leave about 3 inches of lead and secure the coax to the toroid with a zip tie. Wind 6 turns tightly around the core. Each time the coax passes through the center hole, it counts as 1 turn. After the 6th turn, instead of continuing in the same direction, cross the coax across the face of the core to the opposite side. Wind 6 more turns in the opposite direction. You should have a total of 12 turns, 6 plus 6. The crossover acts as a bridge, meaning your input and output leads are now 180 degrees apart. Use UV rated zip ties at both ends of the coax to ensure the windings stay tight against the core. If the turns are loose, the impedance characteristics can shift. Once wound, you need to strip the ends of the RG316 to connect them to your hardware. Carefully remove the outer jacket, pull back the braid and strip the inner dielectric to reveal the center conductor. Solder the center conductor to the center pin of your SO239 connector. Solder the braid to a ground lug attached to the connector body. On the output side, for a coax out, repeat the process to a second SO239. For wire out, solder the central conductor to one stainless steel bolt for the antenna leg A and the braid to the other antenna leg B. FT240 means it is a 2.4 inch diameter core. It is large enough that it won't easily saturate at 400 watt peak envelope power. RG316 has a silver plated copper clad steel center and a PTFE, that is Teflon dielectric. It is rated for significantly higher temperatures than standard RG58, making it safe for 400 watt even if the SWR is slightly high. Use a multimeter to ensure the center to center and braid to braid connections have 0 ohms resistance. Ensure there is infinite resistance between center conductor and the braid. If mounting outdoors, ensure your enclosure has a small weep hole at the bottom to allow condensation to escape. To give the most accurate picture of your balance performance, we need to look at the common mode impedance Z subscript S. For a 1:1 current balun, we want this value to be as high as possible, ideally above 2000 ohms, to effectively choke off unwanted RF. The total impedance is a combination of inductive reactance X subscript L and resistive loss R subscript S, expressed as ZS is the square root of the combination of RS squared and XL squared. For 12 turns of RG316 on an FT240 size core, here is how the choking impedance generally stacks up across the bands. For 160 meter band, 31 mix gives a common mode impedance of 1200 ohms, while 43 mix gives only 400 ohms. So type 31 is better for low end. At 7 MHz of the 40 meter band, it becomes 3500 ohms for mix 31 and 2100 ohms for mix 43. So type 31 is at peak performance at 7 MHz. Moving to 14 MHz or 20 meter, mix 31 has 3000 ohms impedance, while mix 43 will give 4200 ohms impedance. That means type 43 starts to take the lead on 20 meter band. Coming to 28 MHz or 10 meter, the impedance is just 1100 ohms for mix 31, while it is 2500 ohms for mix 43. So type 43 maintains higher impedance at that frequency as well. The W1JR crossover isn't just for neatness, it minimizes stray capacitance between input and output turns. By crossing over to the other side of the toroid, you physically separate the high voltage and low voltage ends of the coil. At 400 watt, if your antenna is well matched with SWR below 2:1, the balun will stay cool. However, if you are using this with a non-resonant doublet and an antenna tuner, the common mode currents can be much higher. The Teflon dielectric of RG316 won't melt until it hits roughly 200 degrees centigrade, whereas standard RG58 would fail at 80 degrees centigrade. After a long transmission or a contest run, safely check the core temperature. If it is too hot to hold, you may need to stack two cores. Glue two FT240s together to handle the flux density. You may know that when the temperature goes high above the Curie point of the core, its magnetic properties will be lost.